Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this video of the International Fuel Gas Code. My name is Thomas and we are in Chapter 4, Section 402. In this presentation, I'm going to give another example of the branch length method. I've explained that in a previous presentation, but let's look at a different type of system. In this system, everything is CSST. It runs to a manifold and branches to all the appliances. This is a really common way for people to run gas pipe within a building. So this branch length method may be very useful to you. Get out your books and let's get started. All right, are you still with me? We've completed example 1, and hopefully you can see the difference with the branch length method. Not only were we using different types of pipes, but we were using different distances on our table to get the most precise system. Once again, not as conservative, but really quite accurate, and especially for our different types of pipe. Let's look at branch length method example 2. We'll follow the same 6-step process as we size this one out. Have a look at the diagram with me and examine the difference with this system. Let's look at the system information first. We have a 6-inch water column for inlet pressure. We're using natural gas, specific gravity 0.60, but this time the trunk line and the branches are all CSST. So we're going to use that same table as we're looking at this. Check it out. Point of delivery is the meter. We have a single line coming in to a manifold. We're going to call that line A. And then everything else are branches from the manifold. B is a branch to the furnace. C is a branch to the water heater. D is a branch to the range. E is a branch that heads to the dryer and the room heater. And it splits to each of those for F and G. Each of these branches has the respective distance or length associated with them. So we should be able to sort this out. Step 1, we looked at all of the BTUs. We've got them listed from the furnace to the room heater with the respective BTUs per hour. Steps 2 and 3, we need to find our section lengths and our branch lengths. So we've gone ahead and noted all of that on this diagram. We can use that on our table to find the specific total length for each branch. Now for section A, we're dealing with the trunk line that feeds the manifold. We have to go with the longest length from the point of delivery to the furthest appliance. As we look at that, we have 45 feet. Follow that out. The furthest distance is the dryer and the room heater. They're equal in distance from the point of delivery, both furthest away. So we're going to go E has 20 feet, and either one of those has 5 feet. And for that reason, we're going to have 45 plus 20 plus 5. We'll have a total length of 70 feet. For the rest of these, we're going to take that main section, 45 feet, feeding the manifold, and then just add the distance to the appliance. So with branch B, we have 45 feet and 15 feet going to the furnace. 45 plus 15 is 60 feet. For branch C, we have 45 feet from the point of delivery to the manifold and 10 feet from the manifold to the water heater. 45 plus 10 is 55 feet. For branch D, we have 45 feet to the manifold, 20 feet to the range. 45 plus 20 is 65. For branch E is carrying both the dryer and the room heater. We're going to size it using longest length going to one of those appliances. So for E, F, and G, we'll take 45 feet to the manifold plus 20 feet on section E plus 5 feet. 45 plus 20 plus 5, all of those are going to be 70 feet. Now we have our lengths for section A and for all of the branches coming from the manifold. We are now ready to calculate the cubic feet per hour for each section and branch. We've got them all listed out on the table. Notice this time we have variable lengths, but we've got our BTU per hours listed. The total for the whole system is 221,000 BTUs. That's being carried by that main line headed towards the manifold. We divide that by our BTU per cubic foot. and we get 221 cubic feet per hour. Branch B is running to the furnace. It has 80,000 BTUs, so we get 80 cubic feet per hour. Branch C to the water heater, 36,000 BTUs, so we get 36 cubic feet per hour. Branch D is running to the range with 52,000 BTUs, so we get 52 cubic feet per hour. Branch E is running to the dryer and the room heater, combined total of 53,000 BTUs, so 53 cubic feet per hour. Branch F runs to the dryer with 28,000 BTUs, so we get 28 cubic feet per hour. And branch G, 25,000 BTUs to the room heater for 25 cubic feet per hour. We are ready to do some sizing. We'll want to make sure to select the correct table. We know we are using corrugated stainless steel tubing, so we go to that table, verify our pressure and gas type, and we know we're using table 15. So we are ready to size the section and branches. Please remember, we're doing branch length method, so our lengths are going to vary. We may be using different lines on the sizing table depending on the branch. But we'll use the length, we'll use the cubic feet per hour. Let's go to it. We've got section A with 70 feet, 221 cubic feet per hour. Section A runs from the source, the meter, to the manifold. We have 70 for our developed length, so we'll follow our lengths down till we come to line 70, and we have 221 cubic feet per hour. We come across, it's a ways over there, it's more than 121, it's more than 141. It will fit within 248 cubic feet per hour, so we go to the top of that column and find that we will need a tubing size of 37, and we can put that on our table. Let's go to branch B. Developed length here is 60 feet to the furnace with 80 cubic feet per hour. That's running from the meter to the furnace. We'll take that distance of 60 and come down to line 60. We have 80 cubic feet per hour. It's more than 68, but there is a column here that has exactly 80, so we can stay in that column, go to the top, and we find a tubing size of 25. We'll put that on our table. Let's go to branch C. We have a distance of 55 feet and 36 cubic feet per hour. Branch C runs from the meter to the water heater. There is not a row here for 55 feet, so we'll have to go on to line 60 on our length, and we're coming across with 36 cubic feet per hour. That's more than 34. It's less than 38, so we can stay in this column, go to the top, and we find a tubing size of 19. We'll put that on our table. Let's go to branch D. We have a length of 65 feet and 52 cubic feet per hour. Branch D is going from the meter all the way out to the range. There's not a line for 65, so we'll go down to line 70. We're coming across with 52 cubic feet per hour. That's more than 36, but that's less than 63, so we can stay in this column, go to the top, and we have a tubing size of 23. We'll put that on our table. Let's go to branch E. We have a length of 70 feet and 53 cubic feet per hour. Branch E runs from the manifold up to the dryer and room heater where they split. We'll take our distance of 70 and come across with 53 cubic feet per hour. It's more than 36. It's less than 63. So we come to the top and we find tubing size of 23. We'll put that on our table. Let's go to branch F. We have that same 70 feet and 28 cubic feet per hour. F is heading up to the dryer. So we have 70 feet. We'll come down to line 70. We have 28 cubic feet per hour. That's more than 16. It's less than 31, so we can go up to the top and find a tubing size of 18. We'll put that on our table. And finally, G, we're going 70 feet. We have 25 cubic feet per hour. G is running over to the room heater. We'll go to line 70 with 25 cubic feet per hour. That's more than 16, less than 31. Come into the top again, and we find 18 is our tubing size. And we'll put that on our table. We've done it. We've sized out all of the sections of the system. Now you may still need to, for your own benefit, convert these over into inches. Most of the time though, when you're ordering CSST, you can order according to the EHD sizing. We still have one other method to examine. Make sure to check out the videos on the hybrid pressure method so that you understand the difference on how we size those. And I will see you in the next one.